We've done a lot of polishing on the engine interaction, and I wanted to make a video to go over it and show how all of these polish features work together. So I'm going to start off in 2D mode here. This is the non-VR sort of desktop play. As I mentioned before, you can switch freely between the two. And I've got a couple new tools here. This is a tool for locking the crankshaft, and a similar one for locking the camshafts. So if I throw a ratchet on the bolt, I can now turn the engine over with tools. And you can input engine rotation from the crankshaft or the camshafts. And they're geared, so it's easier to turn the engine over at the crankshaft than the cams. And then we've added a developer tool for now to quickly remove assemblies. So if I push a button, I can remove all the dependent parts in the valve cover, so I can quickly remove it. So that just undid all the bolts. And now if I switch into VR mode, just push a button and pick up my controllers. So I can turn the engine over, and then if I take the belt off and I turn the cams actually have to overcome a spring force, and they want to index into those positions where there's less force. And what's cool about this is actually based on the assembly status. So if you were to half build ahead and only put, say, half the valve springs in, you'd get a different behavior than if you have a fully built head. And the same thing with the crankshaft. The weight of the turning is based off of how far the bottom end is built. And then we can modify it for things like, does the engine have compression or not? And then here's the locking tool, so I can remove the cam gear. And you can see now I can remove it, otherwise it just spins. This one spins. And then you can't install the belt, obviously, when you don't have the cam gears installed. And if I put this back on, I can't actually install it until I lock it in place. So I'll put the lock tool back in, and I can tighten it down. So I'm going to torque this down. I think I'm aiming for 25 foot-pounds, but then I overshoot it. And put the belt back on. So now if I want to demonstrate the crankshaft lock, I'll have to take off the damper. So it's these 4 bolts, there's like a washer plate, and then the damper slides off. And the crank bolt's installed at 160 Newton meters. And this tool's too small to actually generate enough force to break it free. So I can lock it, but I can't actually remove the crank bolt right now. I'd need a longer handled tool, a breaker bar or something. But if I slide it over, the assembly's locked and I can't turn it anymore. So again, if this is a bigger tool, I'd be able to break that bolt free, but I just can't right now. And then also we've implemented turning things by hand. So this is something that's going to be carried over to fasteners later, but you can twist your hand on a grab to give it a small turn. And there's a maximum force you can generate with your hand, and it's not actually enough to overcome the spring force on the cams. But it's a nice thing, like if you're putting a crankshaft in, you want to see if it spins freely, you can just give it a little twist. And then maybe we can do things like hand threading fasteners, or if you want to remove the oil cap, we can have you hand twist it off. And then lastly, one more thing we've implemented is that the teeth are forced to index between the belt and the gears. So if you tweak all the positions so nothing's lined up, and you go and you put the belt on, you'll see everything moves just a little bit, just to force it into alignment. And that just prevents the teeth from the belt from sticking into the gears. And then you can see here how much harder it is to turn the assembly when you're attached to the cams than when you're attached to the crankshaft. And that's just the mechanical advantage of the gear ratios.